Which one am I supposed to get rid of?
Okay. Matthew's down at the pulpit. What does he need? Matthew?
Pull the power off of it?
Unplug the little white bullet one?
Checked it.
So your compass would work on Mercury. It would point north. And that was a bit surprising for the secularists because Mercury is very small, and the smaller the object is, it's kind of like smaller batteries. They don't maintain their charge. Remember those old D cells we used to use? They rarely use them anymore. But they lasted a long time because they're big. And so Mercury's like a AAA battery. And so its magnetic field should not last billions of years, but it's still there. And so that's an indication that it's not billions of years old. In fact, there's evidence that it's decayed even between the two times we visited Mercury back in the 70s and then more recently, just a decade ago. So that's Mercury, real slow rotator, and not a place you want to visit on your next vacation. Did you have a question? Why did Pluto get demoted? Because one thing, it's a lot smaller than anybody expected. It's only 2/3 the size of Earth's moon. When it was first discovered, they thought it was as big as Earth. And they said, well, maybe it's as big as Mars. It's hard to tell because it's far away. You can't see any size to it, so they had to make guesstimates of how big it was. But one reason is it's small. The other reason is they found another 20 or so objects that are nearly as big as Pluto out at that same distance. So you either got to remove Pluto or, in fairness, add another 20 planets to the solar system. And think of the children who have to memorize this stuff, right? So bad enough having to memorize 8. So that's one reason why that happened. Okay, so let's go away from Mercury there. Now the next planet out from the sun is Venus. And Venus has been called Earth's sister planet because it's about the same size as the Earth, just very slightly smaller. Very slightly smaller. There's Venus. That's what it looks like. And lots of interesting things about Venus. One is it rotates backwards. That's kind of neat. The sun would rise in the west and set in the east. Although you never see the sun because Venus is permanently enshrouded in thick clouds. It's got an incredibly thick atmosphere, 100 times the atmospheric pressure of Earth. And clouds that cover it completely. It would always be overcast on Venus. It would be very depressing. But that would be the least of your problems because the surface temperature on Venus is 900 degrees Fahrenheit. It's even hotter than Mercury because Mercury doesn't have an atmosphere to trap the heat. Venus does. And so even though it's further out, it traps in heat. The atmosphere is mainly carbon dioxide. And by the way, this is why the climate alarmists are saying, see, you got to watch your carbon dioxide emissions or Earth's going to end up like Venus. That's not possible. Venus has 100 times the atmosphere of Earth. Earth couldn't possibly end up like Venus. It's not possible. Carbon dioxide is a mild greenhouse gas. But on Venus, there's a lot of it. 100 times more than we have on Earth. So anyway, so it's nothing to worry about. Now, we now know what the surface of Venus looks like because we had a spacecraft orbiting it, the Magellan spacecraft, and it used radar, and radar can go through those clouds and bounce off, and it was able to image the surface of Venus, and so we now know the surface of Venus looks like that. Here's what it looks like. And sometimes you'll see in textbooks, you'll see pictures of Venus like that. That's a radar map. That's not what it actually looks like. That's what the surface would look like if you could remove the clouds, which you can't do. So that's not what Venus looks like in a telescope. In a telescope, Venus looks like that. It is pretty featureless, but it does go through phases, and phases represent where the sun is relative to the planet and then Earth. And it's fun to watch that. It's fun to watch through Venus go through phases. Galileo saw that and realized that Venus had to be orbiting the sun. Because if Venus was orbiting the Earth, it wouldn't go through phases like that. It's very clever. It's good reasoning. So there's Venus, backwards rotator. By the way, the secularists don't really have much of an explanation for that backwards rotation. Very difficult for them to explain, because in the secular view, if the solar system collapsed from a spinning cloud, conservation of angular momentum should cause all the planets to be spinning the same way and upright. And Venus is just exactly the opposite, just exactly backwards from what the secularists were expecting. So I think God did that just to confuse them a little bit. Maybe bring a little bit of humility too. So again, Venus is not a place you're going to want to visit. It's got, with that surface temperature of 900 degrees Fahrenheit, and it's a slow rotator. It takes over 200 days for it to rotate once. So that would be very strange. So again, it's not designed for life. It's not like the Earth is. Yeah?
So are you saying for Venus, there is no scientific explanation for its backward rotation
Right.
other than the hand of God?
I think so, yeah. I mean, the secularists do try to explain the backwards rotation, but they'll say, well, it got hit by something. But I've done the calculations on that, and you'd have to hit it with a bunch of asteroids in this, like 100 Ceres type asteroids at the same location. The probability is very low. So, yeah. So next planet out is Earth. It's my favorite planet. All my friends live there. It's got the best restaurants. Most spatulas of any planet. I don't know. It's a unique planet and it's beautiful. And what a privilege that we now have images of our planet from space. And it's stunning. It really is. A friend of mine is an astronaut he just retired actually, but when he had downtime on the space station, he'd go and take pictures of the Earth from the space station, and they're stunning. And one time we did a presentation, he did it right after mine, and so we put his PowerPoint on my computer to save time so we wouldn't have to switch. And I said, Jeff, I'm keeping your PowerPoint. He said, that's fine. He said, but it's really stunning. So this is simulated, of course, but that's basically what the Earth looks like from space. It really is. It's a beautiful planet, and what a privilege to live on this blue marble, this gem. Mostly covered with water, 71% covered with water, which is an essential for life. And so we think that's a design feature, and it makes sense. God says that he formed the earth to be inhabited in Isaiah 45:18. So the earth is designed for life. It has a protective magnetic field. That magnetic field protects us from cosmic rays. Cosmic rays are bad. They can cause mutations, which can give you cancer and things like that. So we have an invisible shield protecting the earth. That's pretty neat. And that magnetic field is decaying, as it would have to, which indicates the earth can't be millions of years old, or the magnetic field would be gone by now. So that's an indication of the youth of the planet. Earth has plate tectonics, so that its crust is divided into plates that can, under certain circumstances, can be moved. And we think that's the mechanism that God used to cause the flood and also to end the flood, is plate tectonics. So the one planet that God knew he would need to flood, he made it floodable. He designed it that way. The Earth's the only planet with plate tectonics. Other planets have geology, they have tectonics, but not plates. They don't have movable plates like the Earth does. So that's pretty neat. Polar ice caps. There's the southern polar ice cap. The ice caps grow in the winter, shrink in the summer, which is opposite for northern and southern hemisphere. And that's due to the tilt of the Earth. The Earth is tilted about 23.5 degrees. That's a design feature. If the Earth were tilted more, seasons would be extreme. You'd have incredibly hot summers, incredibly cold winters, and that would be destructive to life. If the Earth were not tilted at all, you wouldn't have seasons, but it would reduce the Earth's habitable zones. You would have fewer places on Earth where life would be possible. It would make the equators too hot and the poles much too cold. So the tilt of Earth is a design feature. So that's kind of neat. Of course, we have mountains and valleys on the Earth, and a lot of those are a result of the plate tectonics. There were original mountains on the Earth before the flood. We think they were smaller than the ones today. But the Rockies, those are flood mountains. Those are caused by the flood. Pretty neat. And then the Earth has a moon, which we call the moon. You need to understand, until 1610, the moon was the only moon we knew of. It had not occurred to anybody that other planets could have moons. And then in 1610, Galileo pointed his telescope up at Jupiter and saw that Jupiter has 4 moons orbiting it as well. But before that, it was just the moon. So there's the moon. We always see the same side of the moon, this side, because the moon rotates. People think it doesn't rotate because we see the same side, but it's orbiting the Earth. And so to keep the same face pointed at the Earth, it would have to rotate, right? So if you were to watch it from space, you could see it is rotating. It's just we always see the same side. One side faces the Earth. That's tidally locked. And all large moons do that. They keep the same face pointed at their planet. That's an energetically favorable configuration. There's the Earth in the background. So isn't that neat? I've always been a little envious of the astronauts that got to land on the moon and look up and see the Earth. And wow, what an experience that would be. Man, that would be a weird feeling. But I guess we're going back, and I look forward to that. I hope the Artemis program is successful. So that's kind of what it would look like. The moon is a design feature because it keeps the Earth's oceans, it causes tides, which keeps the Earth's oceans from stagnating. So it oxygenates Earth's oceans, and that's a design feature. Because we need the oceans, we need diatoms in the ocean to produce oxygen. Most of our oxygen comes from diatoms in the ocean. It's not from trees and grass. It's mostly from the ocean. So that's a design feature. The moon has remnant magnetism. That means it's got little bits of magnetic field on its surface. And that's an indication that it can't be billions of years old, because magnetic fields decay with time, and even remnant magnetism. Remnant magnetism means the moon once had a magnetic field like the Earth. That's decayed away, and so it's got just bits of magnetism left, and those are decaying as well, so they can't be billions of years old. So that's a neat indication that the moon is not billions of years old. And the moon is unusually large relative to its planet, so that's kind of neat as well. So there's the Earth. Wouldn't want to live anywhere else. I'd like to visit other planets, but I like living on this one. Now the next planet out is Mars. And although Venus has been called Earth's sister planet, Mars really is the planet that's most like the Earth, although it's only about half the size of the Earth. But it has a lot of similar features. It's got mountains and valleys and canyons like the Earth does. If I spin it around here, this large, you see this large, looks like a big scratch mark there. That's an enormous canyon. It's called Valles Marineris. It's much bigger than Earth's Grand Canyon. In fact, that would span about the width of the United States. So it's enormous. It's not a water canyon like the Grand Canyon. It's a tectonic fissure where the crust is broken apart. Mars doesn't have plates, but it does have tectonic activity. Massive mountains on Mars, volcanic. You can see 3 of them here, 1, 2, 3, and there's a 4th one there. It's enormous. Those are volcanic mountains. And this big one right here, that's Olympus Mons. That's the largest known mountain. It's a volcano. They're all thought to be extinct, but they might just be dormant. We might see them erupt at some point. The secularists think they've been dead for billions of years. We creationists think they might erupt at some point. So it'd be fun to see that.
How tall is that?
It's 3 times taller than Mount Everest. Yeah. Although it's very broad, the base of it would cover Iowa, so it's a shield volcano. It's not a stratovolcano. It's a shield where they're kind of shallow. So yeah, pretty amazing. We roll it around. We got valleys and canyons and so on. Here's that light feature down there, that big circular feature. It's an enormous valley called Hellas, and it sometimes fills in with fog and looks quite bright in a telescope. People mistake it for the southern polar ice cap, which is actually further down. So, but anyway, Mars is a neat planet. It's got polar ice caps like the Earth does. There's the northern polar ice cap right there. You can see that a little bit. And they grow in the winter and shrink in the summer, just like Earth's ice caps. Although Mars's ice caps are mostly carbon dioxide, frozen carbon dioxide, dry ice. A little bit of water ice too, but mostly dry ice. Mars does have the molecule H2O, but it's in the form of vapor or ice. It doesn't have liquid water because it doesn't have enough atmospheric pressure to hold liquid water. Although there are dried riverbeds on Mars. So at one point it had water. And we think that's probably a temporary condition. Ron Samick has a neat model for that. He's a creation physicist, and he believes that when Mars volcanoes go off, they temporarily increase the atmospheric pressure enough to where you can have liquid water fall as rain, and he thinks that's how you're getting these dried riverbeds. So, yeah.
About the moon, why not get so red for the whole thing in the 339?
The moon, why does it look red? You're asking why it looks red sometimes?
Yeah.
Yeah, it's because when it's low in the sky, it'll do that. And that's because of what's called Rayleigh scattering. Light from the moon, the moon's actually pretty gray. But when you're looking through a lot of atmosphere, the blue gets scattered away, and that leaves the red. The same reason sunsets look red. So when you're looking at the sun and it's low in the sky, all the blue has been scattered away, making someone else's sky blue, and that leaves the red for you to see. So the moon has the same effect. But Mars is genuinely red, and that's because it's made of basically rust. It's oxidized iron. So it's a rusty planet, basically. So it is genuinely red, yeah.
Is Mars the one they really feel that they can colonize that in the future?
Yeah, so yeah, Mars is the one they want to colonize. And if you wanted to colonize a planet, Mars would be the best bet to start with because it'll kill you slower than the other planets. Yeah. I mean, Venus, you're dead. I mean, Venus, 900 degrees, those clouds are made of sulfuric acid type compounds. The atmospheric pressure is 100 times the Earth. It'd crush you like a tin can. You're going to die quick on Venus. Mars would kill you a lot slower. If you bring a little bit of Earth with you, you could survive on Mars, we think, for maybe 2 years. And then at that point, you'd have to leave because the radiation on Mars is higher than on Earth because it doesn't have that protective magnetic field. Yeah. Does the Earth kill us too? Well, yeah. Well, Earth is what's giving us the protection from death. I mean, you leave the Earth, you leave the confines of the Earth, you die almost immediately. But God designed the Earth to be inhabited, so it has all these life features, oxygen and so on. And originally on Earth we would have lived forever, but it's because of sin we don't. So we killed ourselves when we decided we wanted to rebel against God, and we chose death. So, but Mars would be a nice place to visit, but again, I wouldn't want to live there. But it is similar to Earth in the sense that it's got seasons like the Earth because it's tilted about the same amount. So it has summer and winter, right? The rotation rate, 24 hours, 36 minutes. That's pretty neat. So you could sleep in an extra half an hour every day. I think that's cool.
So what is the surface like? Like we have dirt and stuff here. What is like the surface of these?
So with, the other plant, they're rocky. All the plants we've looked at so far would have a surface similar to Earth, other than there's no life, there's no plants on them. So Mars in particular, it would have a soil, a lot of rocks, and then dissolved soil, which is rocks broken up, basically sand, things like that. So a sandy, rocky surface is what we're looking at on Mars. Yeah? It's colder than Earth. It's generally below freezing, but occasionally it might get up above freezing. Yeah. Okay, so there's Mars. Mars has 2 moons, and they're tiny. They're called Phobos and Deimos. Names mean fear and terror, because Mars is the god of war, so fear and terror. Here's Deimos, and it surprises people that small moons are not always round. It's basically a big rock in space. It's about 10 miles across, a little less than 10 miles across. So there's Deimos. Isn't that neat? And then the inner moon, Phobos, it's a little bigger than Deimos. It's a little bigger than 10 miles across, but not much bigger. So there's Phobos. And they're not quite round because the gravity's not strong enough to pull them into a spherical shape. So their internal chemistry can prevent that. But the gravity's so weak, you could pick up a rock on Phobos and throw it into orbit. You could watch it go over the horizon, and then you could catch it as it comes up over the other horizon. So that'd be kind of neat. And Phobos orbits really close to Mars, too. So you could look up and see Mars. And I think that would be a weird feeling because the gravity's very weak. You'd feel like you could almost jump off. And then there's Mars right above you. That would be a strange feeling. So it's interesting to see these situations that don't occur on Earth. So Mars, similar to Earth in many respects, but different from Earth in many other respects. It's got a real thin atmosphere of carbon dioxide, so you can't breathe on Mars. If they ever send people to Mars, they'll have to have suits like they did on the Moon. And then the gravity would be about half that of the Earth. So, and then there's no liquid water on Mars as well. So again, it doesn't have all these design features that Earth has. It does have remnant magnetism like the Moon does, which indicates it can't be billions of years old. The magnetic field would be gone. Now those inner planets are called terrestrial, meaning Earth-like, because they're solid, you could land on them. You'd have to bring a little bit of Earth with you to survive, other than Venus, which would kill you almost immediately. But Mars, you could, if you brought a little bit of Earth with you, you could survive for a little while. The outer planets are very different, especially Jupiter and Saturn. They're balls of gas. They don't have a solid surface. So Jupiter, for example, you can't land on Jupiter. There's nothing solid to land on. It is a ball of gas. Now the gas probably becomes so compressed it becomes liquid at some point, but there's nothing solid to land on Jupiter. So what you're seeing is a giant ball of hydrogen and helium gas, made of the same stuff as the sun, but whereas the sun is almost pure hydrogen helium. It's got trace elements. Jupiter does too, and its trace elements can form molecules, which doesn't really happen too much with the sun other than titanium oxide. But Jupiter has hydrogen, helium, and also has methane and ammonia. And those gases give it the wonderful colors that it has. The methane especially is responsible for the orange color that you see there on Jupiter. And then because it's a ball of gas, its clouds get stretched out into belts and zones. That's what you're seeing there. Those are clouds. And the white ones are called zones. The dark ones are called belts. So belts and zones. And the zones are higher than the belts. So if you could remove the white, it would all be orange. The white is above the orange, so to speak. And if you watch it rotate, you can watch those move. Yeah? It's still a planet, yeah, because it's big. It's 10 times the size of the Earth, so it's big, and it orbits the sun. That's yeah, yep. So size does matter apparently. Size does matter because Jupiter's 10 times the size of the Earth. That's big enough to make it a spherical shape, but it is a ball of gas orbiting the sun. And so basically, you know how Earth has jet streams, right? That's what you're seeing on Jupiter. It's just Jupiter's, they're colored, and so you can actually see them. Earth has only about 3. It's got a polar jet stream, and then the kind of the mid-northern jet stream, and then the equatorial, and then the southern too. Whereas Jupiter has like 9 because it's a bigger planet, so it can have more jet streams. So that's what you're seeing there. Pretty amazing, really, to think about that. And then the other interesting feature on Jupiter, if we roll it around here, this great red spot, which astronomers call the Great Red Spot, because we're not very creative. And what that is basically a giant hurricane on Jupiter, or an anti-hurricane. It's a high-pressure system. And hurricanes on the Earth are powered by heat from the ocean. When a hurricane goes over the ocean, the temperature drops 10 degrees after the hurricane goes by. So it's powered by heat. And then what happens on Earth, hurricanes, then they go over land, they get cut off from their power source, and they peter out. Jupiter has no land. So that red spot has been there for at least 300 years. It may have been there since creation for all we know, but since we've had telescopes powerful enough to see it for the last 300 years, it's been going and going and going. Yeah?
How did you know that there wasn't a planet under all that?
How do we know there's not a solid surface under that? Part of it is the density of Jupiter. Jupiter has moons that orbit it, and from the period of those moons, we can compute the mass of Jupiter, so we know how much stuff is there, and then we can see how big it is, and you divide the mass by the volume, that gets the density, and the density is consistent with hydrogen gas, so the whole planet has to be essentially hydrogen gas. If it was solid, if it had a solid rocky surface, then the density would be much greater. So that's one way they can do it. They can do it with spectroscopy too. Yeah. Isn't that neat? So there are good reasons to believe that. Yeah.
I'm always surprised at how colorful everything is.
Yeah. Except the moon.
Yeah.
Yeah. Yeah. Yeah, the Lord has a sense of beauty, and it's not just confined to the earth. Other things that the Lord has made, they're stunningly beautiful. I love looking at this stuff through a small telescope. It's a blast. And I like seeing other people see it through a small telescope and seeing their reaction too. It's a lot of fun. But Jupiter is beautiful. It really is. So again, you get other storms that develop on it too, but they sometimes absorb each other, and sometimes they'll get sucked into the red spot. It's fascinating to watch weather on Jupiter. It's just amazing. So, and we know it has lightning and things like that. We've seen that with our spacecraft. So pretty amazing. Jupiter has an incredibly powerful magnetic field, and it's a big planet. So even in 6,000 years, it's really maintained that magnetic field. But again, over billions of years, it should be gone. So that's a problem for the secular view, and Jupiter's internal heat as well. Yeah.
Well, this may be oversimplified, but what actually do you see as the people of Aberdeen? What is the purpose of all these planets? Is it basically because of God's power, or do they? I understand the moon and gravity, but what is their purpose?
Yeah, multiple purposes. We know from Scripture one purpose for which God made the lights in the heavens. Part of it's to give light on the earth, but the sun mainly does that, and the moon. The stars give a little bit, and the planets give a little bit, but also to be for signs, seasons, days, and years. In other words, to be time markers for us. So you can think of the moon is how we measure months. The rotation of the earth is how we measure days. The motion of the earth around the sun is where we get years. But then how do you know which year it is? Planets. The position of the planets will tell you which year it is. Each of them you can think of like a hand on a clock. Okay, so the moon would be like, or the rotation of the Earth would be like the second hand. The movement of the moon would be like the minute hand. The Earth going around the sun would be like the hour hand. And then the planets are like additional hands that tell you which year it is. So that's one reason, is to keep time. And that was, we have other ways to do it. We have artificial ways to do it now. But before that, you relied on astronomy to tell you the time, to tell you when to plant, when to harvest. And then one other reason, to declare God's glory, right? Psalm 19:1, the heavens declare the glory of God. Yeah. So, yeah. How big is the red spot? It's about twice the diameter of the Earth. So you could put 2 Earths right in there. It is shrinking. So this is an older image, about 2 Earths across. It's now about 1.5 Earths across. So it's shrinking a little bit. We don't know if it's going to go away or what. We don't really know. Weather on Jupiter, it's fascinating. Jupiter has a bunch of moons, 4 big ones. And these were discovered in 1610. And these were the first moons discovered other than Earth's moon. And that was because Galileo was one of the first owners of a telescope, because he built his own after hearing it had been invented in 1608. He built his own in 1609, and by 1610 he was looking at it and seeing all kinds of new stuff that nobody had seen before. And he saw these 4 little stars that were always in a straight line next to Jupiter. And night after night they switched places. And so he could tell that they were orbiting Jupiter. And to him they were just little stars. But today we visited them with spacecraft. And so we know what they look like up close. And so let's go to little Io or Io. This is the innermost of the 4 large moons of Jupiter. There's Io. I love Io because it looks like a pizza. Either that or an orange that you forgot you left in the refrigerator. Yeah. So there's little Io or Io. And it looks so strange. And it's very colorful. It's made up of sulfuric type compounds. If you've ever been to Yellowstone, the area, the geyser area, it looks similar to that. That's because it's the same chemistry. It's a lot of sulfur compounds. It's the most volcanically active world in the solar system. Volcanoes are constantly going off on Io. When Voyager 2 went past Io back in 1980, around there, it discovered 9 volcanoes going off at the same time. And that's what those little spots are. Those are not impact craters, they're volcanoes. Each one of those is a volcano. And it's been completely resurfaced since creation by the volcanic outflows. So it is very volcanically active. And that's what gives it those unique colors. So I love that little moon. It's about the same size as our moon, but it's far more colorful. It makes me feel like we got ripped off on our moon, to be perfectly honest. But I'm sure the Lord had a reason for that. But isn't that beautiful? And then the next moon out is Europa. Europa is just slightly smaller than our moon. And again, just fascinating. And it's got these large scratch marks on one side, like a big cosmic cat came and just swiped it. And we think those are geysers where liquid water is spewed up and then as water vapor and then falls back onto the surface. So we think it has internal heat too. Internal heat like that is an indication it can't be billions of years old, because things cool off with time. And so it still has some internal heat that's producing those geysers, we think. So it's still a little bit speculative. And then the next one out is Ganymede. Ganymede is the largest moon in the solar system, 50% bigger than ours. So there's Ganymede. And it has a unique beauty to it. It's kind of got these 2 different shades of brown and then these white craters with white ejecta. Very pretty, I think. I think it's a beautiful moon. And it's actually bigger than the planet Mercury. But because it orbits Jupiter, it's a moon. If it orbited the sun directly, it would be considered a planet. It's big enough. So there's Ganymede. And then outermost of the big 4 is Callisto. And there's Callisto. So to those, Galileo saw those as 4 little bright spots. And frankly, if you have a small telescope, you pointed out that Jupiter, it's in the morning sky right now. You pointed at Jupiter, you'll always see these 4 little spots. Occasionally one of them is behind or in front of Jupiter and you don't see it. But usually you see 4 little stars, always in a straight line because Jupiter's edge on relative to us. And so the moons orbit like that, right? So now those 4 inner moons, sometimes called the Galilean satellites after Galileo discovered them, they all orbit in the same plane and in the same direction. Let's see if I can do this right here. Nope, that's the wrong one. There we go. So you can see they all orbit in the same plane, in the same direction. There's 4 moons that are tiny and interior to those 4. And that's a design feature. There's not a lot of space available there. So they have to be organized so they don't crash into each other. And so that's a design feature, actually. But if you go out further away, there's plenty of space available. And so the outer moons, and there are many, Jupiter has, I forget what the latest number is, but it's something like 80 moons. And I think they've discovered more than that. They keep finding more, and I can't keep track, to be perfectly frank. Back when I was a kid, there were 16, and I knew them all, but now there's 80, and I'm like, I can't keep track. So here's the outer moons. Yeah. And if we speed up time, a lot of them orbit backwards. Look at that. And not in the same plane. If we rotate the systems sideways, they're all... It looks very messy, but each one of those is a perfectly elliptical orbit. It's just they're all oriented different. And it might look crowded, but there's plenty of space out there. That's millions of miles. So that, again, is a design feature. Inner moons orbit in the same plane, in the same direction. Outer moons do what they want. That's a common feature among other planets, same way, if they have a lot of moons. So that's fun. So that's the Jupiter system. Next out we have Saturn. Everybody's favorite, right? So here's Saturn. Let's set it to the way it would look today. That's the way it would look today, if you were there. My mouse has just died. Now let's do it this way. So there's Saturn. And Saturn's similar to Jupiter. It's a gas giant. It's a ball of gas held together by its own gravity. It's about 9 Earths across, so it's just a little smaller than Jupiter. But of course, the thing that makes Saturn amazing is that lovely ring system. Now Jupiter has one too, but Jupiter's rings are so thin you can't see them without special equipment. Saturn's are thick. And what they are, they're trillions of tiny little moonlets that are orbiting around Saturn's equator. And so many of them you can't see individual particles, but they blend together, and that forms that ring system. So really spectacular. And the Lord was kind enough to tilt that planet so that we could see those rings. Because if he didn't, you would never know that they were there. Yeah. Now even here you say, well, I can see the shadow of them. That's because it's tilted relative to the sun. But if it weren't tilted relative to the sun or the earth, you would not know that it had rings. And so it's kind of the Lord to have tilted it so that we could see that ring system. There's a famous photo of Saturn that looks kind of like that. Saturn in a crescent phase. Stunningly beautiful. And people, I think, don't realize the significance of that. You cannot see Saturn in a crescent phase from Earth. In order to see something in a crescent phase, you have to be farther away from the sun than the object. And so the photo that looks like that is proof that we've been there. We've sent a spacecraft past Saturn. And as it was going past Saturn and looked back at it, it got Saturn in a crescent phase. Really stunning. So I think it's a privilege that we have spacecraft that can do that. So Saturn has a bunch of moons as well. Yeah.
Can you say again what creates the rings?
Trillions of tiny little moons. Yeah. Boulders, dust, particles, trillions of them. Yeah. And then it has moons as well. This is the moon Mimas. And this is not a great simulation of it, but there are pictures of Mimas. It has a massive crater on one side. You can see it there. And this big crater right there. Massive. Whatever hit it probably came close to breaking the moon apart completely. But from a certain angle, it looks just like the Death Star from the Star Wars movies. So I like Mimas. So that's kind of fun. Some other moons. Let's see. Let's go to Titan. Got to do Titan. Titan is Saturn's largest moon, hence the name. And it is orange. It's so weird. And you can see, if you have even a modest telescope and you point it at Saturn, you will always see an orange little star next to it. That's Titan. It's always there, orbiting around Saturn. And it's orange because its atmosphere contains hydrocarbons. Things like gasoline's a hydrocarbon. So it's made of that. It would rain gasoline on Titan. So gas would be really cheap on Titan. On the other hand, oxygen would be expensive, so count your blessings, right? So it's the only moon that has a thick atmosphere like that. Most moons don't have an atmosphere, or if they do, it's very thin. Titan's the exception. Got a thick atmosphere. We've penetrated it using radar, because we had the Cassini spacecraft go past and orbit Saturn, and it used radar to penetrate the clouds. That's what the surface of Titan looks like. And it actually has lakes of methane, which is wild. And that was something that was not expected because methane is destroyed by ultraviolet light from the sun. And so if Titan had been orbiting for billions of years, the methane should be gone. And yet its atmosphere is made of methane. And tholins, the orange is tholins, which are methane that's already been destroyed by ultraviolet light. Because even in 6,000 years, some of it's been destroyed. But the fact that there are lakes of methane, some methane, but mostly methane, indicates that Titan cannot be anywhere near billions of years old. So that's again, there's a lot of stuff like that in the solar system. You tend not to hear about it because it goes against the secular narrative. So another moon of Saturn that I really like, it's called Iapetus, and it orbits a little bit further out. But I like Iapetus because it's so weird because on one side it's dark as charcoal, and then on the other side it's white as snow. So really neat. And astronomers were perplexed because when it was on the right side of Jupiter, they couldn't see it. It seemed to disappear because you're looking at the charcoal side and it's hard to see. And then it was on the left side of Jupiter, they could see it easily. Or left side of Saturn, pardon me. So isn't that amazing? You can see it when it's on one side, not when it's on the other. And that's wild. And yeah, that's impressive. We think we know why that happens. There's another moon out that has debris coming off of it. And that debris collects on the leading hemisphere of Iapetus. And so that's what causes that darkness. And the remaining side, snow basically. So really pretty. And Iapetus is far enough out. It's the first moon out that doesn't orbit in the ring plane. The inner moons all orbit, remember, because that's a design feature. There's not a lot of space available. And so they all orbit in the same plane, which means you couldn't see the rings because you're in the same plane as the rings. So if you wanted to build a base on one of Saturn's moons, you want to pick Iapetus because then you can see the rings, okay? Because it orbits out of the plane of the rings. So there you go. The outer moons are like Jupiter's. They kind of do what they want. But we're going to move on for time's sake. Okay. Okay, that helps. Now, back in the 1980s, a wonderful thing happened. First of all, technology had developed to the point where we could start sending probes out deeper into space. So 1970s is when Voyager 1 and 2 were launched, and they went out past Jupiter and Saturn. But the neat thing was, in the 80s, the planets, the outer planets, Jupiter, Saturn, Uranus, and Neptune, happened to line up in this big arc to where we could use the gravity of one planet to slingshot a spacecraft to the next one, to the next one, to the next one. And so Voyager 2 was able to visit Jupiter, Saturn, Uranus, and Neptune because the Lord was kind enough to providentially line up those planets right at the time technology developed to where we could do that. That doesn't happen very often. That doesn't happen very often. So we were able to visit the planet Uranus in 1986. So there's how the planets were lined up in 86. It already passed Jupiter, Saturn, and then it flies past Uranus in 1986. Uranus is tilted on its side. And again, the secularists they just scratching their heads on that because it should be this way, it's this way. So it spins like that. It rolls around the sun. Okay? And when Voyager 2 flew past it, one hemisphere was pointed right at the sun. So we saw I guess it depends on how you define it, but you could define that as the northern hemisphere of Uranus. And today, it's the southern hemisphere that's pointed at the sun. But and then the moons all follow suit because I wish the mouse worked. I think the battery just went dead. That's okay. The moons all follow suit because they're orbiting around the planet's equator, right? So there you go. Let's look at some of the moons. When I was a kid, there were 5 moons orbiting Uranus. We now know of at least 20 or so. But here's one of the inner 5. This is Miranda. It's the only one I've not been able to see in my telescope. The other of the big 5. The other 4 I've been able to see. But Miranda's smaller than the other ones. And it's got this weird surface that looks like it's been broken apart and reassembled, right? It's got this big inverted check mark that you see there on the right side. So really strange. So that's little Miranda. And then next out would be Ariel. You're wondering about the names. Uranus is interesting. Uranus was discovered by William Herschel, and it was the first planet discovered by telescope and in modern times. All the other planets had been known from antiquity. William Herschel was an Englishman, and he wanted to name the planet Uranus after King George. He wanted to name it George's star, Georgius Sidious. And the French really didn't like that. A lot of politics in astronomy, you'd be surprised. But the French did not want it named after the English king, so they said, yeah, we're not going to do that. And so the international astronomical community ended up naming it Uranus after the Greek god of the sky, because it has this beautiful, Uranus has this beautiful sky color, right? The planet does. And you can see that there. It's sky colored, really pretty. And so for that reason, they named it Uranus after the god of the sky, in keeping with ancient tradition. Although it was named after a Greek god, all the other ones are named after Roman gods. So Uranus is an exception there. And then when they started finding moons around Uranus, which they did almost immediately, because they're substantial enough, you can see them in a small telescope. They're faint, but if you know what you're doing, you can detect them. And so, and they decided, granted, we can't name it after King George, but maybe we can at least name the moons after characters from the greatest English playwright, Shakespeare. And so most of the moons are named either after Shakespearean characters or after Alexander Pope's The Rape of the Lock. So it's the only planet where you're allowed to do that, where you're allowed to name them after Shakespearean characters. Little quirk of history there. Uranus has a magnetic field that's consistent with its biblical age of thousands of years, and that was something that Russ Humphreys predicted, because he's a biblical creationist. And so based on that biblical age, we were right, the secularists were way off. And then, yeah, let's try it. Is it double A?
Double A.
Double A. If you can, it's okay. And then the next one out, Neptune, which was visited in 1980. No, not Pluto. I don't want to go to Pluto yet. Open script. Let's try this again. Thank you. Try that again. Thanks. Yeah, there we go. Thank you. So here's Neptune. Neptune's kind of a twin of Uranus. They're almost identical. They're the same size, 4 Earths in diameter. Kind of an ice giant. It's got a real thick outer atmosphere like Jupiter and Neptune, but it might be icy, or kind of a slushy, icy mix, much deeper down. Beautiful blue color. I love the color of Neptune. It's so pretty. And it has this great dark spot, which astronomers call the Great Dark Spot, right? And it's real similar to Jupiter's red spot, although it's a low pressure system. It's more like a traditional hurricane. And unlike Jupiter's red spot, this one comes and goes. Sometimes it's not there, because Hubble can see that. And sometimes there's a different one that appears in the northern hemisphere. So it's not as stable as Jupiter's red spot. But beautiful blue color caused by Rayleigh scattering, same thing that makes our sky blue. So there's Neptune, and it has a strong magnetic field like Uranus, which indicates its age cannot be billions of years. Okay, so that's another indication of the youth of this planet. And its internal heat. It gives off more than twice as much heat as it receives from the sun, which means it would be an icicle if it were billions of years old. It would have lost all that energy a long time ago. It's like a potato that you take out of the microwave. You can still feel the heat coming off of it. Neptune's still got heat coming off of it. So God took it out of the microwave not too long ago, okay? 6,000 years, okay, because it's big enough it can do that, but billions of years can't be. It's got a number of moons, but one of them is really interesting, and that's Triton. Triton is a fairly large moon, and it orbits Neptune backwards. It's the only large moon that orbits its planet backwards, and in a highly tilted orbit. So there's Triton. That's what it looks like. By the way, you'll notice sometimes some sections of this are blurry. That's because the spacecraft flew by this system, and when it was far away, it photographed that side. So it's like taking a picture far away. And then when it got closer, it got pictures of the other side. So that's why it's in more detail. You'll see, when we go to Pluto, we'll see the same effect. So, and if we zoom in on this, there are these black streaks all over Triton. See those black streaks there? They're kind of horizontal. Those are geysers. Those are where it takes soot and it ejects the soot up into a thin atmosphere, and then the prevailing winds carry the soot and deposit it in horizontal streaks. So that was totally unexpected, because Triton's smaller than our moon, and so it shouldn't be able to maintain internal heat to power those geysers. So the fact that we find geology and geological activity in the solar system is an indication that these worlds are nowhere near billions of years old. And we find that on almost all of them. So it's pretty amazing. Not surprising from a creationist perspective, but it is amazing. It is amazing. So there's Neptune, and one of its more interesting moons. It does have a lot of other smaller moons. That's the only big one that it has, and it's not that big. Triton's not all that big. So there we go. That's the Neptune system. And then we'll go out and do Pluto next. We'll end with Pluto. Pluto, I had to wait for Pluto because when I was a kid, it was a planet. And we'd visited, by 1989, we'd visited all the planets except Pluto, and I really wanted to see what Pluto looked like. Had to wait till 2015. The New Horizons spacecraft, which was launched in 2006, as fast as we could get a spacecraft there, it took 9 years to travel the 3 billion miles to Pluto. And here's what it found when it went to Pluto. The secularists were expecting a world completely covered with craters because Pluto's been orbiting for billions of years. Pluto's only 2/3 of the size of the Earth's moon. And so there shouldn't be any geology on Pluto. There shouldn't be mountains or valleys. It should just be covered with craters because everything would have hit it over 4.5 billion years. Now there are some craters on Pluto, but there's not as nearly as many as they were expecting. And there's an entire region where there are no craters at all. Sputnik Planitia. There are no craters in this section right here. Instead, you find this weird, it looks like a jigsaw puzzle. See that? We think that was magma or liquid at some point and is overturning cells, convection currents. And that indicates internal heat on Pluto, which means it can't be billions of years old. And then it's got mountains on it too. You can see those mountains there? There's a good set right there. Those are mountains about the size of the Rocky Mountains. That's about how big they are. They're made of ice instead of rock. At that distance, ice is as hard as rock because it's that cold. So, and then there are some craters, but there are these canyons too, these massive canyons, and that's interesting. That indicates geology. See some of those canyons there? That's wonderful. So that indicates that Pluto is nowhere near billions of years old, and it also has a large moon called Charon, about half the size of Pluto. That's kind of neat. And Charon likewise has lots of interesting features, interesting geology, mountains, some craters, but canyons as well. You can see those canyons there. Massive canyons, just amazing. A dark North Pole, which nobody was expecting. That's kind of neat. So that's kind of fun. And then they started naming the features on these. I don't know if they'll stick, but let's see if I can show you the names of the features. I really like this because I'm a sci-fi buff. And they started naming the features after sci-fi characters. So you have Vulcan Planum, Spock Crater, Kirk Crater, Sulu Crater, Uhura Crater. We go over here, Ripley Crater, Skywalker Crater, Vader Crater. And they call this region Mordor, so Lord of the Rings didn't escape either. I don't know if those will stick or not, but that's what the team at NASA decided to name those, and I approve. Anyway, so that's the Pluto system. It has 4 smaller moons as well, but it has 1 big one and 4 small moons. So really interesting little, we now classify it as a dwarf planet, but it was a wonderful, wonderful world to explore, and I'm glad we got to do that. And it just reminds me again of the special beauty of our own world, Earth, and that of all these planets, this is the one where God became a man and paid for our sins and walked on, and that's awesome. That's something to think about. So we really are very blessed, and I want to thank you very much for having me out to speak. Hope you enjoyed that.
All right, well, you ready to do it again?
Yeah.
All right, well, let's migrate.